Okay, hello Year 7. Welcome to Mr. Ali's Lessons Online. Welcome here, and we have an exciting recording to do for you today. The lesson is on algorithms with sequence. Last week we learned about algorithms. We went through an algorithm worksheet, and of course before school broke up we discussed that algorithms are like a recipe. It's a sequence of doing things in a specific order. And we're going to talk about that a bit, about that specific order, how that works, and whether there's some wiggle room in there. But first, before we get started, a few people I want to give some shout outs to for doing some superb work, turning it in, and going the extra effort. We've got Asia, we've got Ginevra, Isla, Kanisha, Amanda, Nishita, Estrus, Computing Club, and Natalia have all done superb work in the past week or two. And I just want to say thank you and well done. Bring your homework in, do well, go the extra effort. You can get a shout out to from Mr. Ali on Year 7 computing lessons. Hope you're well. Hope everyone's staying safe and staying engaged during lockdown. I know it can be tough. I know it can be a bit boring at times. I know there's schoolwork still to be done. Sorry about that, but we need to learn. We need to get some good stuff going on. And what we're teaching you here in computing class is really valuable for computational thinking. These are skills you can learn and use all through life, whether you're a doctor, a lawyer, a grocery store worker, if you drive a truck, or if you drive through legislation in the Houses of Parliament as the UK Prime Minister. You too can use computational thinking for your advantage and to help make society better for everybody. But let's move smartly along here and let's look at what our lesson is for today. Now, you've gotten some instructions to go into the RoboMinds Academy and to look at that and work through the first little bit. If you'd like, go ahead and sign up for that because there's some superb computational thinking, but also programming. That's a lot of fun. And that's what I want to make it as much as possible. Learn lots and have a good time doing it. If you have any doubts about that, talk to some of our computer club people at Coding Club. We used to do that every week. So, starting smartly along, let's have a look at our PowerPoint here. Let's see, PowerPoint. And there we go. So, we're looking at algorithms and programming with regards to sequencing. Now, the thing about sequencing is, like, as we explained with the algorithms, things work like a recipe. They're things similar to tying your shoe, brushing your teeth. These are very simple algorithms. An algorithm in programming works the same way. But there can be some issues within the algorithm we need to look at. Firstly, let's see, we want to understand what we want to mean by sequence. We want to be able to create an algorithm with sequence and to be able to create the code to make it follow an algorithm. And we'll look at that in just a second. Firstly, as we said, shoelace tying, teeth brushing, or cooking or preparing food to a recipe is an excellent example of an algorithm. And in our example, last week, we used the example of making a smoothie. So let's have a look at that. We have a flow chart, decide which order the instructions go below. And the instructions are all set up here out of order. So the flow chart is there on the right, and these have specific meanings that we'll get into later on. But what we want to ask ourselves is, are these instructions in the correct order? And you can pretty much look at that and say, no, they're not. So a lot of you sent in your homework. You had those in the correct order, and they approximately went in this order. So you start, if it's a program, it has to start. You add your strawberries and bananas, you add your milk and ice cream, and then you look to see, is the blender full? Now, 3 of those lines I have in green. And the reason is, you could add the milk and ice cream first, and then add the strawberries and bananas after that. That's absolutely fine. Shouldn't affect the recipe one bit. Is the blender full? Now, interestingly, a couple of people put is the blender full after you put on the lid or after you turn on the blender for 30 seconds. And as goes smoothies, I have one every day for lunch, and that's fair enough. I let you have that. So after you've turned on the blender, it will mix everything up, but it's also going to churn in some air and make it nice and fluffy if it's not too full. And that might make the blender a bit fuller. So you could look there and say, is the blender full? Okay, end of the program. I'll let you have that. So this is an example of a recipe where some of the internal bits of the sequence don't necessarily have to be in a specific order. They can come before or after other elements of the program. In programming, occasionally this will happen as well. It's important to look very closely at the program just to make sure that what you have in the sequence doesn't affect something badly further along in the sequence. But if we look at the flow chart on the right hand side, this is how the flow chart should look. So the first element is the start, then we add the strawberries and the bananas, we add the milk and the ice cream, those two can be swapped around. Then we come to a decision point. Is the blender full? Yes or no? So we put on the lid. We turn it on for 30 seconds. If the blender's full, we put on the lid, we turn on for 30 seconds, and then we end because we have a nicely made, very, very tasty smoothie waiting for us. If the blender's not full, we can go back just after the start. We can add more strawberries and bananas, we can add milk and ice cream, we can add both, we can add one or the other and suit it to taste. Then we come back and ask ourselves, is the blender full? Okay, maybe now the blender's full. We're going to put on the lid, turn on for 30 seconds, we have our smoothie. And that's the example of an algorithm to make a smoothie and how that works. Now, let's look at a slightly different algorithm. Let's see how this is affected by the order of the sequence, and it's important. So imagine we have Algorithm Burger. We're going to buy a burger at Algo Burger. So here in the sequence, you can see we place an order, we pay for our order, and then we collect our order. Does it have to be in that order? Does the sequence have to go in that order? Let's have a look at it. So here's the sequence we have here. As we've said, the customer places the order, customer pays the order, meal is delivered to the customer. Each step is an instruction to be performed, and the sequencing is the order in which the steps are carried out. Is this important? Well, let's look at this. Let's have say the customer pays for the order is delivered to the customer, and then the customer places the order. Now, will that work? Or will that be a bit silly? How can Algo Burger deliver the order to the customer if they don't know what the order is yet? Okay? Now, say we swap that around. We say the order's delivered, the customer places the order's delivered to the customer, but the customer hasn't been paid. Will some of the customers drive away without paying? Maybe, maybe not. But Algo Burger doesn't want to take that chance. So what they do is they create their algorithm in the order that they wanted to, so that the customer places the order, they know what they need, the customer pays for the order, so the order's paid for before the customer gets the order, then the customer has the order delivered to them, so they receive what they wanted, and everything works nicely. So the sequencing is the specific order in which the instructions are performed in the algorithm. These are important, and in most programs it's very, very important the order in which they're carried out, or mistakes can be made and you get the wrong output. So as we saw with Algo Burger, if the customer had his order delivered before he had it placed, you might get fish and chips instead of having an algorithm burger. If they might have gotten the wrong drink, anything in that order might have been incorrect. If the customer had to pay for the order before they placed it, they might not know how much to pay, because they may pay for a more expensive meal instead of the less expensive meal that they wanted to order. So this is the reason that in most cases in an algorithm, the order is very, very, very important. Okay, so for your assignment this week, I've asked you to go to the Robo Academy and sign up there. Now, what we want to look at is how the Robo Academy works really quickly. So I'm going to cut over to my screen and give you a quick demonstration on this so we can see what you're going to be doing. Once you come to the Robo Academy and you press the go button, Robo the robot is going to grab the green object, do a little spin about, a happy dance, and that's it. So what you want to do, as per my instructions, is come up here. There's a little video you can watch. It's interesting. It gives you more information about RoboMinds Academy. But if we go ahead and click on the second button after that, you're going to see this screen. So what we want to do is write some code up here so that Robo the robot can go correctly the number of squares, go next to the green object, and picks up the green object. Now, at the moment, the code isn't correct. So what we want to do is a couple of things. One is we want to look at using a variable. So we've got turn right, go forward one step, of course, go forward one other step, but that's a lot of work. What if we could take that out and delete that step and say go forward 3 squares? And we add that in as what's called a variable. Now, the thing about the word variable is there's some clues to what that means inside the word. It's variable. That means it can vary. It can change. So, for the moment, the variable forward has 3 steps. It means to go 3 blocks forward. So down here on our screen, we go 1, 2, 3. Then he's going to turn left. Once he turns left, he's going to go forward 1, 2, and then at that point, he's going to run the next part of the programming algorithm in the sequence is to pick up. That means he's going to pick up the green object. So, now that we've got this here, let's try it again and see how he does. So he turns right, goes forward 3, turns left, goes forward 2, picks up the object. Superb. It's done exactly what we want to. Now, what I want you to do is to come over here on the screen, here in the upper right, bring the screen back so that you can see there's a second green object and it's hidden behind several barriers. So from here, Robo wants to go a certain amount of steps forward, come around the objects, and either go down, oh, we can't go through there, that's not going to work, so he wants to come through here, down along, stand next to the object, and pick it up. How does that sound? Using these types of commands and the information you have here with the help files, can you create an algorithmic sequence of programming commands so that Robo can come through here, come around the barriers, stand here, and pick up the object? That's the challenge. Let's see who can do it. And what we want to do, and this is important, is to understand that typing commands into a screen creates output. And it creates output that you can see on the screen, and it's output that's useful, in this case for Robo picking up the green object. But later on, a couple of ways you can see output that's helpful for you. It gets you the output that you want. That's great for GCSEs, it's great for A-levels, but also, did you know, you can make maths much, much easier if you use programming. You can make other subjects much easier if you use programming. In business studies, oh, it's just tremendously easier if you can crunch numbers using programming. And programming makes that really easy. Secondly, what we would like to do, if possible, is to use programming languages to create a game similar to this. We won't do this in year 7. We might look at how we can do that in year 8. But we want to make it interesting, we want to make it a lot of fun. But your challenge is to see if you can get Robo to pick up that green object, screenshot that for me using the instructions up online, and I will give you a shout out if you can do that and present that to me via OneDrive. Thanks a lot, and I hope this was interesting. Come on the chat and Teams. If you have any questions, drop me an email. That's j.alley@hfed.net, and I will be happy to help. I'll be happy to answer that. Okay? Have a good week, and I look forward to seeing that homework in my inbox next week. Cheers. Bye-bye.